Here is Anmol Saxena from BSc second year, roll number 215037, and the topic is projection theorem. So in projection theorem, the first thing is orthogonal projection. We have to understand what is orthogonal projection. So in this, if we take a projection of u vector along x and y axis, so we can say along this side we have w1 projection, and in upward side we have w2 projection. So we can expand u vector in two components, that is component of u vector along a vector and component of u vector orthogonal to a vector, that is w1 and w2. So we can write u vector as the sum of w1 vector and w2 vector. So here we know the w1 vector is the component of u vector along the a vector, and from this substituting the value of w2, we get w2 vector is equal to u vector minus w1 vector, which is the component of u orthogonal to a vector. From the above case, we can write w1 vector and w2 vector as a sum of u vector. By putting all these values, we get w1 cancelled out, and the remaining vector we get u vector, which proves that u vector is the sum of two vectors which is along and perpendicular to a vector. So this is all about the orthogonal projection. So now we have projection theorem, which is totally based on the concept of orthogonal projections, and it states that if u and a are the vectors, and if a is not equal to 0, then u can be expressed in exactly one way in the form of u equal to w1 plus w2, where w1 is the scalar multiple of a and w2 is the orthogonal to a. So in the proof, we are having the same concept as the orthogonal projection. Since we know w1 is the scalar multiple of a, then we can write w1 equal to ka. As we are getting w1 equal to ka, the remaining part we have to find is k and w2. So to find these, we can write u as a sum of w1 and w2. From the 1, we on putting the value equal to ka plus w2. So on taking the dot product of a on the both side, we are getting u vector dot a vector equal to ka dot a vector plus w2 dot a vector. Since w2 is perpendicular to a, so we know that the scalar product of perpendicular vector is 0. On putting the value, we are getting k as u dot a upon the a square. From 1, we are getting the value of w1, and which is known as the orthogonal projection of u along a. Since w1 is the projection of u along a, so here is the formula to find the value of w1, and on putting the value from the very first equation, w2 equal to u minus w1 equal to u minus projection of u along a, we are getting the formula for w2. So here's we are getting the formulas for w1 and w2, which find the whole value of u vector, and it's all from the projection theorem side. Thank you.